Suppose a robot has a straight arm that can change its length as well as rotate about the origin in a coordinate plane. If the robot's hand is initially at 1212, approximately how many degrees should the arm be rotated and how much should its length be changed to move the hand to negative 1610? Well, let's sketch a coordinate plane in which this robot's arm will rotate. It's attached to the origin and its initial position is at the point 1212 on the XY coordinate plane. Its final position is at the point negative 16, 10, so we'll go back 16 and up 10 and estimate the location of the robot's arm at the end. We're asked for the angle, theta, through which the robot's arm should rotate, and the change in distance between its distance here, which we'll call R1, and its distance here, which I'll call R2. So we want to know both theta and the difference between R1 and R2. Well, R1 can be calculated as the using the Pythagorean theorem. We have a right triangle here whose legs are both 12 and whose hypotenuse R1 we are trying to find. So we can write R squared equals 12 squared plus 12 squared, or R is equal to the square root of 12 squared plus 12 squared. That's 2 times 12 squared under the radical, and so we can break that apart as the square root of 2 times the square root of 12 squared, or just square root of 2 times 12. R2 similarly can be found by doing the square root of 16 squared plus 10 squared. I'll use a calculator to work out the values there. Alright, I've done that, and the square of 16 is 256, the square of 10. I suppose I properly should have the negative 16 here squared. Of course, the negative sign goes away when you square it. Square of 10 is 100. Add those together, you get 356, and this simplifies to the square root of, let's see, 4 times 89, which means we can pull out the 4 as a 2 times square root of 89. So that gives us the two lengths of the robot's arms at the initial time and at the final time. The difference between those two will give us part of the answer to this question. So let's get an approximation to R2 minus R1. That should be 12 square root of 2 from R1. Oops, correct that. That should be 2 times the square root of 89 from R2. We're doing that first. Take away the 12 times the square root of 2 from R1 and use a calculator to get an approximate value for that. We get approximately 1.90, or approximately 1.9 feet, if feet are indeed our unit. So that's the change in length. Let's find out the change in the angle. The angle here is a 45-degree angle. We can see that because it's a 12-12 pitch. And so when we have an isosceles triangle with the two sides, two legs have the same length there. To find out the angle here, this reference angle theta r, we can use again our right triangles. This is a distance of 16 feet. This is a distance of 10 feet, and so I can work out the value of theta r here by doing tangent of theta r is equal to opposite 10 over adjacent 16. And so theta r, using a calculator, can be found by doing the inverse tangent of 10/16. That gives me approximately 32 degrees. So this is 32 degrees. In order to find out the change, what I can do is take 180 minus 32 degrees to get 148 degrees from here all the way up to here. If I then subtract the 45 degrees from that, I'll get the angle change, which is 103 degrees, which should be the change in the angle. Change in the distance is 1.9 feet, and we're done.